Okay, some of the students have problem in this numerical, so I am demonstrating it. In this numerical, what you people have to do is you have to investigate the effect of balloon diameter on the mass of helium. Actually, you are increasing the mass in a balloon, okay, and on the other hand you have to specify the temperature, the pressure remains constant to 100 kilopascal, or in the second part you have to solve the same manner, but you have to fix the pressure value up to 200 kilopascals. After that, they also showed how the diameter of the balloon is varying from 0.5 to 15. Actually, they are not give us the initial amount of mass. They have given us the initial amount of diameter. So we will determine how much mass is required to develop the balloon of 0.5 diameter. And one more thing which they have notified is the temperature of throughout the process remains constant. So in the final, what we have to investigate is we have to plot out the mass of helium against the diameter for both cases. Okay, so firstly I want to solve it in the whiteboard so you people easily understand. Okay, so there you are. Oops. Okay, so we made the data first. Case 1, pressure 1 is equals to 100 kilopascals. For case 2, we have 200 kilopascals. Okay. On the other hand, they notify us that the temperature remains constant to 20 degrees centigrade. If you will convert it into Kelvin, it becomes 293 Kelvin. And furthermore, what you are required to know is the value of R, which you will consider here as 8314 joules per kg mole Kelvin. And your diameter is ranging from 0.5 to 15 meters in dia. Okay, let's see. Firstly, there is a balloon and you're inserting the mass of helium, He. So, and you are maintaining the pressure constant, temperature constant. So whatever the mass you are feeding in this balloon, all the mass is compensated by the volume, and ultimately you can say that the diameter of the balloon directly affect with the increment of the mass. So firstly, what we will do is we know our simple equations of ideal equation, okay, which is PV equals to nRT, and here we reduce the number of moles into its basic formula, like PV is equals to mass over molecular weight multiplied by R value and the temperature. Although if we talk about a spherical mass, spherical volume of the balloon. So we know what is the formula is V is equals to 4/3 pi r cube. But all these things we are developing the relation in the form of diameter. So what we will do is we will reduce this formula for diameter. So it becomes like this. D/2 is actually the radius. Okay, so we put all these formula in this equation in order to reduce it in the final, or we can easily develop the relationship between the mass and the diameter. So, and this is the volume formula, 4/3 pi d cube over 2. I retain this in this form. You may resolve this equation or simplify this equation, but when you are solving it with the calculator, you don't need to do that. Just make the equation in the calculator and the calculator will solve everything. Mass over molecular weight, RT. So the remaining part is, we know the molecular weight of the helium is 4 AMU, atomic mass unit. So we required mass. So what will be the reduced formula for mass? It will be mass of the balloon, mass of the helium will be equals to the pressure times 4/3 pi d/2 whole cube, bracket close. This molecular weight went there and multiply this whole factor, molecular weight divided by these two values, like over R and T. So this is the final relation which we will get. After that I will solve it in the Excel sheet. Okay, so I will open the Excel sheet here. This mic has a very long wire. So here it is. So P1 is, we know that for A part is 100 kilopascal, for B part 200 kilopascals, temperature values and R values and molecular weight of the helium. So we reduce this in the form of formula of mass, and we know that mass is equals to the pressure. I wrote all these values down here, P1, P2, T, R and molecular weight, and here I have plotted, I have write the values of diameters of the balloon from 0.5 to 15 with an interval of 0.5. okay, so these values are in meters, 0.5 meters, 1 meters, 1.5 meters and so on to 15 meters diameter. So now we will develop the formula of for mass. It will be like mass is equals to the pressure value Okay, for A part we will take 100 kilopascal, which is converted into pascals. Okay, then we will multiply it with a factor of 4/3, bracket open. Just watch this toolbar, formula bar. I'm writing the formula here, 4/3, bracket close, multiply by the value of pi, which is 3.14. Then we multiply this factor with the diameters. Okay, the diameter is just beside here, which is equals to 0.5, and divided by 2, bracket close, which has whole power of 3. Okay, then I have to close another bracket. After that I have to multiply it with the molecular weight, multiply by the molecular weight is 4, which is also present here. Okay, then all these factors are divided by the value of R, which is also here, multiply by the value of temperature, and bracket close, and complete bracket close. Okay, so this is the final value we will get here for pressure 1, and we extend it to 15 meters diameter. Again, we will develop the similar formula for pressure 2, which will be like equals to the pressure 2 here. Okay, and we have to multiply it with the factor of 4 divided by 3, bracket close, and multiply with 3.14, the value of pi. Okay, after that we have to multiply it with the diameter, which is 0.5 divided by 2, power of 3, and whole bracket close. So after that, this factor must be divided by sorry for the interruption of aeroplane, but I kind of stopped that. Okay, where we are, we have to multiply it with the molecular weight as well, like molecular weight, bracket close. Then we have to divide this factor with completely with temperature and multiply by R, bracket close. Okay, so we will get a result of something is getting issue. So this formula has developed. Okay, and we will extend this to 15 meters. Okay, so now we have find all these value. We want to visualize the difference with the graph value, so we insert, go for the graph. Okay, we've selected, select the data. Okay, let's delete that one. I remember I just select this all. It has automatically insert the graph. So this is the graph you will get against these things, in which in x-axis it's automatically select the value of diameter, and on the y-axis it has selected the value of masses, and we can find what is the difference between the mass of pressure 1, which is denoted by the blue line, okay, is far too lower than the mass required to develop the balloon with a pressure of 200 kilopascal. Okay, so you can modify this graph as well to get actual results, like which is the better one. So it is better. I think it's don't need to modify it furthermore. So this is the graph you will get after plotting the values of certain thing. That's it. So I think you can easily understand what this numerical is all about. Thank you very much.